Yeah. Hello class. Yeah, how are we? We are fine. Are you really fine? You are fine. Eh? Now today is another day that we should look at the next topic, and that is topic 6. Topic 6. But before looking at topic 6, it looks to me that people aren't fine. Now, since you claimed to be fine, we could check, not so, and prove it. Now, let me pause just an energizer before we start, not so? A trick energizer. Now, listen to the energizer to see who will be thinking well. Beth is, let me use this other name. Esther's mother has 2 daughters, that is Millie and Precious. Esther's mother has 2 daughters, that is Millie and Precious. What is the name of the 3rd daughter? Yes, Precious. Yes. Esther. That means people are very bright and fresh. Now, I also wanted to trick a magic. Can we give you a magic before we go into this other topic? I think we should hold for our magic for the next topic. I'll give you a calculator. Now, that magic will come in the next topic. Maybe people will have gotten tired when I'm finding out how, or are they tired? Now let's look at topic 6. Shows to me that people are very, very attentive. Yeah. Now the topic 6 today, topic 6 is sequences and the patterns, number sequences and patterns, geometric skills and constructions, not so? Yeah, that was our topic that we discussed before topic 6. This is a bit short, and I think this is just the ordinary work that you do. Now we shall divide it into 2 subtopics. That means we shall look at patterns, and under here we shall see what's a pattern. What's a pattern? And we shall also learn out drawing patterns and the usefulness of these patterns. If we draw them, are they useful? Then we shall also visit the sequences, and under it we shall look at meaning of a sequence. It's a bit very short. Then we shall see some examples of sequences. Then we shall visit types of sequences. Yeah, that's right, types of sequences. Then lastly, rules of generating sequences. I think we can separate it from what we call the term of a sequence, called the nth term of a sequence. Right away, it's called the nth term. Yeah, when we finish that, then that topic will be through. Let us start with number patterns. Patterns now. Patterns. Now, before we discuss what's it and how can we draw them, I will demonstrate by just placing a few boxes here. I'm drawing out boxes, and that's the first set, then the next set of boxes, the next set of boxes, and the next set of boxes, the next set of boxes. Then we realize I've drawn certain figures there, but I can also draw other things here. I can probably come out with some sticks bending over others, some sticks bending over others. Let me correct that drawing. Some sticks can bend over others. Some sticks bending right away over others. My space can't permit me. Now I've drawn. Okay, since this drawing is a game, not so? It's a game. Drawing is fun. It's fun. Drawing is fun. Drawing, of course, is fun. Yeah. Now, what do you see? Yes, Grace.
I'm seeing patterns.
You're seeing patterns.
Yeah.
What are these shapes? How could you call them?
The ones for A, I think they are kind of squares.
Squares.
Then for B, they are kind of triangles.
Triangles.
Then for C, circles.
Circles. Now, can this be a design on your art? Have you seen some clothes having such designs? And you're calling them patterns, not so? If we requested you to draw out the next set of this pattern, can you draw it out? How do you find out the next set of boxes, especially here? Yes, Grace, you seem to see something.
I think based on the number of the previous boxes, like the first one
Like
has 3.
the first one has 3.
Yes. The second one has 5.
Has 5.
Then the third one has 7.
Has 7.
So based on the sequence, if you see the numbers that are following each other, like +2, 3 + 2, you get 5.
Okay.
5 + 2, you get 7. So the next one will have 9, since 7 + 2 is 9.
That's exactly. Okay. Then what could do? How many are these rods here? You call them triangles, but this is not. How many are these rods?
5.
5. How many? 8. 11. That means you can draw out the next. How many of they be? 14. Then this? 7. 11. 15. That means you are able to draw out those rods. See? Now, these are patterns of squares, maybe representing certain boxes. These can be rods. Rods are like arranged metallic pieces of rods. These can be marbles, not so? Now, what could a pattern mean to you upon looking at this? What's a pattern now? There we can pick our definition. What's a pattern? Yes. Grace.
According to me, I'm just trying to look it. A pattern can be a path of similar items.
A path of similar items. Okay, a path. If they are drawn on your cloth, is it a path? On your cloth, like if it's an art design of boxes everywhere.
Okay, I'm trying to make the flow of items in a similar way.
The flow of items in a similar way. You have a suggestion, Precious? What of Nantale? She nodded the head. I think we can see these are things that have been arranged. Not so? Things, objects arranged in a repeated. We have a repeating fashion of like here we repeat with two arranged in a repeated order to form a certain kind of a design. Are you not forming designs? Yeah, that means the pattern could be defined as the arrangement of lines, shapes, objects, colors, in a repeated order to form a design. I think that speaks very well. Yeah, now that's true. Now the next subtopic was drawing patterns, which we have now discussed here. You have told me very well that you are able to draw out the next, and the drawing will depend on how many are here. Adding two, like here, the next pattern would have you add more to boxes. Then here you'd add how many rods? 3 rods, the other side. Then here you'd add how many balls? 4 balls. But the shaded ones are not changing, not so? Yeah, they're in a regular pattern. Yeah, that's how we can draw patterns. Now, what is the usefulness of these patterns that we are drawing to form a design? What is the relevance to us? What could this speak to you? 3, 5, 7, etc. 5, 8, 11, etc. If you have seen a pattern, then you are seeing a sequence. See? That means patterns are used to generate sequences. That's the usefulness of patterns. Okay, now that throws us to sequences. I hope you have drawn out some patterns for yourself. Yeah, now a pattern is used to generate a sequence. Oh, now before we wrap, what's a sequence now? A pattern gets us a sequence. Yeah. Now we are picking down what we call sequence. And what's now a sequence? What's a sequence here? In case 3, 5, 7 is our generated sequence from this pattern, then what is it? What's a sequence? Then I can grab, since you have already have those shapes in the note. Yeah, what's a sequence to you? Yes, Grace, you're very active. Precious, you are not. Natalie, I don't see any answer from you. Okay. Grace, what's a sequence?
A sequence may be a flow of numbers or items based on their pattern.
Okay. A flow of numbers based on their pattern. Okay. A flow. What do you mean by a flow? A flow. Yes, Natalie, you have a suggestion? Arrangement. The flow means arrangement. It means it's an orderly arrangement of numbers. An orderly arrangement of numbers. Now, that's what we have as our sequence. I think that's the definition. What's a sequence? Orderly arrangement of numbers based on a certain pattern. Now we can throw in here some examples. Can you drop us some examples of sequences? Yes, have people there giving out? Yes, Precious, now this time you are very active.
2,
2,
5,
5,
0. No, 2 and 3.
2, 3,
Yes. 5,
5,
7,
7, 13,
17,
17,
20.
etc. What else? Can we have some? What rule are you basing on this to decide?
Since they are all
Prime numbers. That means they form a sequence of prime numbers. Okay? She has given us the first one, a sequence of. Could we have others? Another suggestion? Yes, I have Natalie, the same. She's featuring
negative 4,
negative 2,
-2,
0,
0,
positive 2, positive 4, 6. What is this that you're giving us? How are you obtaining that sequence? Even?
Not even. You add 2.
You are adding 2. Your rule is +2. Okay, +2. +2. That's very, very creative. You are very, very creative, Natalie. Yeah, very, very creative. Yes, Moksa, you seem to...
It can be the very same one.
Yes.
Patient starting from the positive side, subtracting 2, 6,
6,
4, 2, 0, -2,
negative 2.
and -4.
Oh, very, very high degree of creativity. Now, me, I'll add 1 here. 1, 3, 6, 10, 15, etc. And I'll also add 1 again there. 1, 4, 1, 4, 6, 8, 9, 10, 12, 14. What could this be? Could these ones? Yes?
That one has two ways of finding the answer.
This one has two ways of finding the answer.
Yeah.
What's the next value here?
The next one is 21.
21. What? See, how did you accumulate this? You added this.
Adding 1 plus 2 is 3. 3 plus 3 is 6. 6
Huh?
plus 4
1 plus, you are adding 2 here, you are adding
4, 5.
5.
Then 6.
You are adding 6.
Then 7. Yes.
Hey. Okay. Then here, what's this? This could be a set of even some numbers called. This is a set of? Sure.
A set of counting.
Set of counting, but 2 is not there. There you are. Are you guessing? Oh, you are very, very sure.
I think I'm sure.
Set of triangular number. That's great. You can check that in the previous notes. What of this? This will crack your head. Yes.
I'm just
Try and you say.
4 minus 1 is
4 yes.
4 minus 1 is 3.
That means you're adding 3.
Then 6 minus 4 is
2.
2. 8 minus 6 is 2. 9 minus 8 is 1. 10 minus 9 is 1. 12 minus 10 is 2. 14 minus 12 is 2.
Then?
So it means 14. So now then it's the next figure is supposed to be
17, no? The next one is 16, why? No, 15, why? And next is 16, why? There you are. That's brain cracking. To crack your head. Yeah, people I think are enjoying their numbers there. They are enjoying their numbers. Yes?
I think those are the opposite of prime numbers.
The opposite of prime numbers. Yeah, which ones are those? Composite. Is one composite, one has one factor. That's brain cracking, not so? No. There you are. Okay, people are still thinking hard. Okay, think hard as we go to the types of sequences, then we can pick on. Not so? Huh? You want to try? That means they are rectangular. They can't be composite because one has only one factor. There you are. Okay, you will generate others, not so? Now, let us look at types of sequences without rubbing this part. I think you've recognized that some sequences have an irregular follow-up, not so? Here you are adding 2, you are adding 3, you are adding 4. Here you are adding 2, 2. Not so? Here you are adding 3, adding 2, adding 1. See, this is irregularity. Now, that means we have now two types. There are some sequences which have a which decrease or increase by a certain, by the same amount, then those which increase or decrease by a different amount. That takes us to linear sequences and the types of sequences here that is following here. Types of sequences, where we have the linear sequence and the non-linear sequence, the one which is regular and the one which is not regular. That takes us types of sequences. We have the linear sequence and we have the non-linear sequence. Non-linear. Now, the linear sequence is the one which changes by the same amount. That means it increases or decreases by the same number. I hope you can pick examples. This one is, which type is this? Linear. Non-linear is a sequence which decreases or increases by a different number or different amount. Different amount. Yeah, that's exactly. Can you pick out some linear sequences from here and non-linear? This is non-linear because you have a difference of 1, a difference of 2, a difference of 4, not so? That's being non-linear. Then this is a linear sequence. Yeah, now that's true. And we are leaving those discussion of linear and non-linear to discussion of rules of now generating sequences. Yeah. And particularly we are going to look at generating linear sequences. Non-linear follow certain rules like types of numbers, not so? As rules of generating sequences. And we are saying we have term to term rule, then we have position to term rule, position to term rule, term to term rule. And this is particularly linear sequences. Now consider, we can take examples here before we discuss the term to term rule. Consider the sequences below. Can you give me some linear sequences here? Yes, the first one is 2, 4, 6, 8, 10, 12. It is not so? Now we are going to discuss its term to term what? Rule. Yeah. How have you changed the terms?
By
Adding 2. That means the rule to generate that sequence is called add 2. Add 2. Add 2. Can we give us another one with a different rule?
2.
You have
2, 3, 4, 6.
That's what? 6 and 7. What is the term rule? The term rule is
1.
add 1. Add 1.
That is a non-linear.
She gave us non-linear. Non-linear can't have these rules. This non-linear would have those meaning in terms of the types of numbers. Those are their rules to generate them. Natural numbers is the rule for generating natural numbers, but we are on the rules for linear sequences. Yes?
Can have 2, 0, -2, -4,
-4.
-6.
This is very great level of creativity. You can stop there. What's the term rule there?
Subtract 2.
Okay. Term rule is subtract 2. If you had this one, how? Yes. 4.
8.
16. The term rule. Add 5, sure.
No. If there was 12 after 8.
12. That will be add. Yeah, that's very, very correct. Yeah, the term-to-term rule. Okay. What is the rule for this? 3, 6, 12, 24, 48. What is the rule there? Just brace. Term rule.
Is multiply by 2.
Multiply by 2. Yeah. It seems non-linear, but it's linear for the rule that has a constant change. Okay. Now that throws us to somebody could answer for us this. The term-to-term rule of a sequence is subtract 6. If the first term is 4, work out the first 3 terms. How do we attain that? A guidance? Grace, you want to try? How do we attain that?
Find the first 3
terms. The first term is
4.
First term is 4. The second term would be
4 minus the term which is
6.
To get
-2. The third term
is the second term, which is -2
minus 6, giving us
-8.
8. That would mean your terms are the first 3 terms the question wanted. I want to give you a brain cracker here that you are right there? Yeah. Okay, let us discuss the next rule called the position to to term rule, position to term. Yeah, position to term rule. We are still generating linear sequences. Give us one linear sequence here that you could have. Negative 8. Negative 4.
Then
0.
Negative 4.
Negative 4.
Sorry, positive 4.
Positive 4.
Then positive 8.
Positive 8. Now, to generate, to come up with a position to term rule, we first have to come up with a what? We first have to get a term to term what? Rule, which is, how are they changing? There is plus 4, not so? Plus 4. That means our rule is plus 4. Clear? Then our position to term rule would be this 4 that we have got, this 4 times the positioning number. Now, right there, wait there. Now, this is 4 times the position number. Then, and this, which position is this? First position. Also, which position? Now let me allow me use example as example 2. Is that fine? Yeah. Yeah. To enjoy. You see, they said that you must start. You first don't eat cassava when you are young, but you first eat what? Matoke. Now she started giving us cassava before we ate what? Let us first eat Irish, not so? Let me start right away with 2, 5. Next would be what? 2, 5. Next would be? 7 next. Are we very sure?
10.
This will be 8.
yes.
11. 8 is not so.
Yes.
Now, let me use my kind of a table. Position number. And the next is my terms. How many terms do I see there? I have 2, 5, 8 and 11. 2 is in the first position, not so?
Yes.
Position 1. This is position 2, position 3, position 4. What is the term to term rule? Before you generate the position to term rule, add 3. Add 3. Then, position to term rule would be this 3 times positioning number. Then we shall find out from position 1 first. Not so?
Yes.
3 times the positioning number. Now if you look here, our first term is 2, its position is 1. Not so?
Yes.
What are we going to if 3, because 2, we are trying to generate 2, we shall have 3 times 1, we get 3. How do we get 2?
You subtract 1.
Minus 1. Can we test, does it work for this 5?
Yes.
Let us test. 5 is in position, this 2, and then I'll have 3 times 2 minus
1 to get 5.
to get 5. The rule is correct?
Yes.
Okay. Now can we go to this one here? This one is hardy cone, is it not so? It's a Brutus hardy cones. Position number, not so? Then the terms, which terms do you have? You have -8, -4, 0, 4, and this is in the position. 8 is in position 1. This one, position 2, position 3, position 4, position 5, not so? What is the term to term rule there? Term to term rule is? Are you sure?
Yes.
Add, you are adding the 4.
Yes.
Okay, this is add what? Add 4. Now, how do we get the position to term? It is you yourself to give me the idea. It will be 4, this 4 times what?
Position number.
Position number. There you are. I'm waiting for you. What can we do? Like 4 times 1, do you get 8, -8?
No.
There you are. Think and you see. What do I, yes. Now, Grace, what I saying?
4 times 1, you get 4.
You get 4. How do you get 8?
Then you subtract.
Subtract? Subtract what?
Subtract 2.
Hey. Now you have to first explain to us very, very properly. Please try to explain to us how you arrived at that.
Okay, I thought of a number that when I multiply 4 times 1, I'll get 4. Then 4 minus 12 will get -8.
The test for us, now, does it work for -4? Will it be possible? Test and we see.
Okay.
How shall we arrive at that? 4 times 2.
Is in position 2. You get
4 times 2, you get 8.
Minus 12,
You get?
-4.
That's very true. The rule works. Is that clear? That's very clear. Yeah, I want to test you on this to check how do we get. Somebody should run like a dog. In Uganda they say dukazambwa. You come and you do this. You generate for us the position to term rule for part C, which is 3, 6, 9, 9, 12, etc. Obtain for us the position to term rule for that. Yes, with clear explanation, you can come on. Grace, you Nantale refused to come. Patience, you refused to come.
Yes, was the first
Was the first to.
She can come because
You can give her the blessing to come.
no.
She doesn't want the blessing. Please, Grace, come on. Yeah, be very, very clear. Be very clear. Let me run this first. Be very, very clear to us. Yeah.
Okay, we shall simply draw a table. Having the position number
and then the term. We have 3, we have 6, we have 9, and then we have 12. Then the position of 3 is 1, 2, 3, and 4 for the last one. So finding the position to term rule and position to term rule, it will be the term to term rule, and which term to term rule we have here. Add 3. So it will be 3 times the position number so before we get the preceding things, so we should
Before we get
the preceding things, whether we should add, whether we should subtract, we shall have to first try out when it's just like this. So it will be 3 times the position number for 3. What do you get? 3 times 1, you will get 3. So meaning I think we can end here because it will give us clearly the term without even subtracting or adding anything. Let's try for the second one. It will be the term to term rule, which is 3 times the position number 2. So it will be 3 times 2 to get 6. And for the third one, 3 times the position number, which is 9. Just like that. It's automatic, so we shall not add or subtract anything.
That's very, very wonderful. Now let us go to the nth term and we close this topic called sequences and patterns. Nth term or the term of a sequence. Nth term of a sequence. Now, if you know how to get the position to term rule, then you know how to get the nth term or the term of. Take an example. Give me one sequence. Let me give you mine, 50. This time I'm using. Okay, we can't start with popcorns. Give me yours. The
2, 4, 6,
2, 4, 6, 8, 10. It is not so. Now, how do we get the nth term? It's first get what we call the position to term rule. That means, what's the position to term rule there? Term rule. What's the term to term rule?
it's add
Add 2. Therefore, this would be 2 times position number. What happens? What happens there? The position for this is the first position, second position, third. What can we proceed with? 2 times 1, we get 2. No, we can't add anything.
Yes.
Now, the nth term would now be 2 times n. The position number is now called n. Is that very, very correct?
Yes.
Now, generate for me the nth term for this. Find the nth term for each. 50, 55, 60, 65, 70, etc. Could you generate for me the nth term for that one? Yes. 1, 3, 1, 4, 7, 10, 13. How can we generate for this? I think I should have this time the other two. Want to discuss for this? Let me transfer this more down. 1, 4, 7, 10. Yeah, come and discuss how we would get that nth term. Yes, we have pressures. How do we get the nth term?
First of all, we shall have to find the term-to-term rule, which is we shall add 5. This is the first position, second, third, fourth, and fifth position. So we shall also have to get there. We shall have to work out the position to term rule. Equals to the term to term rule is 5. So 5 times position Let's first work out for the first number here, which is 50. 50 times position number. Remember, the position number is 1. I mean 5 times position number, and the position number is 1. So 5 times 1, which is 5. But now it doesn't give us 50. So
now it doesn't.
It doesn't give us 50. If we multiply this term to term rule, which is 5, times the position number, which is 1. So you add 45. Yes, we shall add 45.
Why? So that we can get
50.
the 50. Say it again.
We shall So 5 times position number, which is 1, then it gives us 5. 5 plus 45, which is 50. But now they are asking us for the nth term. So we shall have to use the term to term rule times the position number, which is n. 5 times n, which is 5n.
You have not finished? So you want help? Yes. Come and help out. Grace, you help out very well here. I think we try to you make sure you start here so that thing is complete.
So I shall explain. I think I'll have to re-explain. So first of all, we shall have to find the term rule, which is plus 5, adding 5. Then the position to term rule, which will be the term to term rule, which is 5 times position number, and here let us first try without adding or subtracting anything. So we shall have 5 times the position of 50, which is the first position. 5 times 1, we shall get 5. So what do you add to 5 to get 50? It is 45.
Say it again. Say it again.
Okay. when we multiply 5 times the position number of 50, which is the first position, to get 1 as the position number. 5 times 1, you get 5. So what do we add to 5 to get 50? That's 45. And that's how I generated 45. Even if the first time I say, you just think of a number, but you have to work it out mentally. So,
Mentally.
yeah. Then the nth term, it is simply going to mean that you have to represent the position number with n. Everything will remain constant. So it will be nth term is equal to 5, which is the term-to-term rule, times n. I think you're seeing the n is representing this position number. So it will be 5 times n plus 45. So 5 times n, you get 5n plus 45. This is the nth term.
Yeah, that's very wonderful. Very wonderful. Yeah, now the word nth means, like you can say 12th term. That means the position is 12. That's why that position number is taking on nth, 12th. See? Now, let me have somebody finishing up with this. That's Nantale. And I think we should rub for her here. And we see that we close. And if Nantale come and take on this 7, 10, 13, come and take on this.
Okay, so we have to first find the term-to-term rule of these numbers, and the term-to-term rule I think it's 3.
You think it is?
Okay, it's 3. Then we have to find a position term rule. That is, we have to find this term-to-term rule times position number. So I'll do this first one. So it's 3 times 1.
Which one?
The first number, which is 1. 3 times 1 gives you 3. So we say the position number represents the n row, something. So it's 3 times n. This one becomes the n. So we get 3n.
First finish up the position to term rule. Is it complete? Are you testing out? Yeah, then give us now. You doubted yourself, not so? She just smiled at the doubt, not so? Yeah, now Grace wants to supplement. Yes, Grace, come and supplement on her. First tell us, is her position to term rule correct?
Her position to term rule is correct, but then the nth term
is incorrect.
Yeah.
Be very clear. Is incorrect.
Okay, the mistake came about here when we tested. Instead we used this as the term-to-term rule.
Say it again.
The mistake came about here when you used the testing instead of the term-to-term rule.
Instead of the term-to-term.
So here it had to be the nth term. You must use the term-to-term rule, which is 3 times the position number n then minus 2. So it will give you 3n minus 2.
Minus 2. Minus 2. Yeah. Thank you. Very, 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 very good. Thank you very, very much. Now, in closure, let us give you this question in closure. Yeah, I want to read it from here. Are you ready? I read it for you? Yeah. The nth term of a sequence is the nth term of a sequence is 4n minus 3. 4n minus 3. Work out the second term, comma, 10th term, and 12th term. Yeah, how are we arriving at that? You want to take us through? Work out the question. Let me write it here. You can read it. It said,
the nth term of a sequence is 4n minus 3.
Nth term of a sequence is what? 4n minus 3. Then do what?
Work out the second term.
Work out the second term. Then
10th term
10th term
and 12th term.
and
12th term.
12th term. Yeah. Yes, did it say something again? Work out the 10th. Okay, you want to take us through that, and you'll you'll be the summary of the lesson. Yeah. Then we can give you the activity of integration and we close this topic. Rush in very fast. Be a bit more clear and elaborate. All patients, you wanted that chance? She should utilize her chance. Okay, go ahead.
Okay, my method may be a bit long, but okay, let me just try. So, if the n term is 4n minus 3, then we shall have to first find the position number, which will be, the position term rule. Which will be 4, because this n represents the position number, so it will be 4 times the position number minus 3. So finding, because this is the term-to-term rule, so if we want to find the number, so meaning the term-to-term rule is add 4.
add 4.
Yes. So positions, we have the position of 2, the second position, the 10, and the 12th position. So it will be 4, which
You
is
have 1 minute remaining.
for the second position, it will be 4 times the position number, the second term, that takes up the second position. So 4 times the position number, which is 2, minus 3, to give us 8 minus 3, giving us 5. And then the 10 will be 4, term to term rule, that is 4, times the position number, which is 10, minus 3, giving us 40, minus 3, 5, 6. Then the term to term rule, 4 times 12, minus 3, giving us 48 minus 3, 45.
Okay.
So the second term is 5, the 10 is 5, 7, then the 12 is 45.
Yeah, thank you, Grace, very, very much. You've been very great. Yeah, you just took us long, not so? She just took us long, but the issue was the required term was now 4n minus. That means if you want the second term means n becomes 2, because n is the position, not so? She just took us long. Why did you take us long? But that was very fantastic. That means the 10th, it means you could not fail the question, not so? That would yield us 4 times 10 minus 3, giving us 40 minus 3, which is 37. Respectively, we do that to the 12th what? Term. Thank you very much for being very, very creative. That means she can sweat with the number until it comes out. Does it mean so? Yeah, thank you. Now we have been discussing sequences and patterns, and we saw what's a pattern, and we drew some patterns, not so? Then we looked at its usefulness in generating sequences, dropped to the sequence, and we realized the meaning of a sequence. We gave some examples. We talked about linear and non-linear under the types. Then we've lastly been seeing rules of generating sequences, and there we go. Let me read for you this activity of integration, and you'll find exercise, more numbers to practice. You'll find them in a book called Learner's Book for the new curriculum, Mathematics for Senior 1. And you'll also visit some other books like School Certificate Mathematics, Book 1. Yeah. There is a family activity of integration goes as follows. There is a family in the neighborhood of your school. There is a family in the neighborhood of your school. The family has a rectangular compound on which they want to put a hedge around. They want to put a hedge around. Then next, the hedge shall be made up of plants of different colors. the hedge is HEDGE, shall be made up of plants of different colors. Then paragraph, the family requests you to plant the hedge around their rectangular compound. The family requests you to plant a hedge around their rectangular compound so that it looks beautiful. So that it looks beautiful. Then the paragraph, explain how you will plant the hedge. Explain how you will plant the hedge. Making sure that the plants at the corners of the compound, making sure that the plants at the corners of the compound are the same in terms of color, Then paragraph, discuss whether there are other ways of planting the hedge. Thank you for attending. We meet in topic 7.